Welcome back, my dear friends. A very good morning, good afternoon and good evening to all of you. This is the DADM, which is Data Analysis and Decision Making, one course in the area of statistics and probability and multivariate statistics. And this is under the NPTEL MOOC lecture series. As we know, this is a 30 hours course and we are in the third lecture, which is in the third day of the first week. And I am Raghunandan Sengupta from the IME department, IIT Kanpur. So, if you remember, we were discussing the problem where it is basically trying to find out the frequency less than type and greater than type, and we had the example where family members, that is the number of members in the family for a number of family in numbers starting from 2 members minimum to 7 members being maximum in a family, and then you can find out the less than type, greater than type frequency and utilize them. So, how you utilize them, that is basically what is being shown in the graph here. So, the example of a cumulative frequency graphs both for the less than type and greater than type. So, if you draw them with the numbers in the family along the x axis and the cumulative frequency being in numbers less than type and greater than type. If you draw them, you will have two graphs. The orange or the red one is basically for the less than type and the yellow one with the triangular marking, and for the orange one is the square bullet points marking. The yellow one is for the it should be basically for the greater than and less than type. So, you have one point which is basically the point where both the curves meet, and we will come to that in the meeting point later on. And so, these are known as the ogive curves, and the ogive curves where they meet have a very particular significance related to one of the central tendencies we will study. We will come to that later on, and central tendencies, if you remember, I mentioned the mean, the median and the mode, and there would be other examples also. A cumulative frequency diagram which we just saw is known as the ogive curves of the less than type and the greater than type. The abscissa of the point of intersection of these two less than type and the greater than type curves gives us the median of the data. So, median basically has a very special significance. I am going to come to that later on. So, there are few bullet points or guidelines for depicting the frequency tables, and it should be remembered in general. The classes should be mutually exclusive and exhaustive. So, when I mean by classes, it is basically the division based on which we are trying to find out the frequency. So, in the class, say for example, if you are making the classes from 0 to 1, then basically from 1 to 2, 0 to 1 means all the numbers less than 1, and the next class is basically all the numbers greater than 1, and then 1 to 2, 2 to 3, 3 to 4. So, in that case obviously the question would come that where would the number 1 lie. So, obviously you have to make the classes very distinctive. So, it can be of from 0 to 1 inclusive of 1 and from 1 to 2 to exclusive of 1. So, based on that you can make a decision where 1 would lie. In another case, it should always be remembered, which is what I just mentioned, is that any particular value should definitely be in one of the class intervals. It cannot be take two positions, that means in class 1 and class 2, and it cannot be that the intersection of the classes has some numbers which cannot be depicted, like the number 1 I said. So, if the classes are from 0 to 1 less than type, less than in the sense 0 to 1 less than equal to 1, and from 1 to 2 greater than equal to 1. So, obviously in that case there is a confusion, because where would the 1 lie. So, it can be either in the first class or the second class. So, that is a type of problem which I have stated. Another can be if the classes are 0 to less than 1 and 1 to 2 greater than 1, in that case obviously the question will arise where would the number 1 lie. So, in the first case it could basically take both the classes, in the second case you do not have any class where you can basically put the number 1. The number of classes should be neither too small not too large, because if it is too large, then obviously trying to find out what type of distribution will fit, that information will be lost. And if it is too small, then it becomes very difficult to find out classes where there are some frequencies. So, if there are no frequencies, obviously it will be very difficult to find them, because in that case the relative frequency or the probability of the chance is 0. As far as practical, the classes should be of equal length. So, as I mentioned in the first example, just verbally which I am saying, if the classes are from 0 to 1, the next class should be 1 to 2, then 2 to 3, 3 to 4, so on and so forth. So, it should not be like this, the class is 0 to 1, then the next one is 1 to 1.5, other one is 1.5 to 5. So, this basically would create a lot of confusion, and then trying to basically put them in those particular classes becomes difficult, and trying to find out the corresponding distribution or the ogive curves obviously do not give us the right result. So, let us consider this following example. The following data relates to the height in centimeters of 40 individuals. So, basically they start from the first value is 160.1, then second one is 167.2, and so on and so forth till the last two values are, if you read along the rows, the last two values are 164.2 and the 164.9. So, obviously they are not written down in the sequential order of from the less than type to the greater than type, that means from the minimum to the maximum or from the maximum to minimum, they are stated as you have collected the data. So, we are required to prepare a frequency distribution table showing the frequencies and the cumulative frequencies. We are also required to draw a histogram to exhibit the frequency distribution graphically. We are also required to draw the ogive curves. So, we will try to basically do the problem accordingly. So, now we basically draw the frequency table for the heights, and let us assume the class intervals which is given on the leftmost column are from 145.95 to 152.95. So, next one is basically 152.95 to 159.95, so on and so forth till the last class interval is 180.95 to 187.95. Now, let us pause here and basically discuss something. Now, obviously, a question may arise in your mind by seeing the class intervals as they have been made. What happens to the number which is basically 152.95? So, the values which are written down for the class intervals considers, after going through the values, is that there are no values which has a value of 152.95. So, in case it was there, so obviously the third decimal places of the class intervals would have been drawn in order to make the class interval such that any one data point when picked up basically goes into first class or the second class or the third class, so on and so forth. So, there is no ambiguity as such. So, now the next column basically gives us the frequency. So, for the class interval of the group between 145.95 to 152.95, the frequency is 6. For the next class it is 5, for the third one is 13, so on and so forth, and we continue, the values are given as 9 to 5. Now, remember one thing, if the assumption which you are made that the class intervals should be of equal division. So, if you find out the class interval 145.95 to 152.95 and the next one from 152.95 to 159.95 and so on and so forth, then the intervals are of the equal dimension or equal breadth. Then in the third and the fourth column, we have the cumulative frequency of the less than type and greater than type. So, if you find out the cumulative frequency of the less than type, the numbers are as written. The first one is obviously 6, the next one will be 6 plus 5 is 11, the third one will be 11 plus 13 is 24, so on and so forth till the last value which is 40. Now, if you do for the greater than type, the values are starting from 40, 34, 29, 16, 7 and 5. So, now we have the less than type and the greater than type, and we are required to basically in the third statement of the problem, it says that you have to draw the ogive curves. So, to draw the cumulative frequency less than type or the greater than type, first specify the class intervals as we have done, then depict the class intervals along the horizontal axis and the cumulative frequency less than type or the greater than type along the vertical y axis. Against each class interval, mark the points by correspondingly putting the cumulative frequency less than type or greater than type value along the y axis. Join the points, which means the values which you have just drawn, to get the cumulative frequency of the less than type and the greater than type, and they would basically be a straight line. That means, between 2 points you are basically joining them by the straight line, and these are the ogive curves. Now, remember one thing, if you remember, I did mention that when you are trying to draw the class intervals, they should not be made too small or too large. Obviously, the question was of making them too small would mean that in many of the class intervals the frequency would be not existing, that means they would be 0. In that case, trying to basically find out the distribution is difficult, but The flip side, on the positive side, is that if you have made the class intervals as minute as possible, then the ogive curves, which I will again show it to you, would be much smoother, which is what actually we want. So, there is the cost benefit analysis in that term, that when we are trying to draw the ogive curves, it should be made as smooth as possible, which will depend on number of such class intervals which you have, and they should be as minute as possible. But on the other hand, the cost, which means that there is no frequency or no relative frequency in those classes, should also be avoided. So, if we draw this ogive curves for the less than type and the greater than type, then for the class intervals are drawn along the x axis. So, the first class interval is 145.95 to 150.2.95, as we have already discussed, and it continues to the last class interval, which is 180.95 to 187.95. So, obviously, the class differences are 7, and along the y axis we have the cumulative frequencies, the cumulative frequency values which I have already shown. And if we note down where the graphs basically meet, this point which I am trying to basically highlight using the red marker, this is basically the median value about which we have talked. So, if I want to find out the median value, I will basically draw along the horizontal and find out along the vertical. So, this will give me the median value. Now, when I mention, I will come to the median value in the next classes. So, when I am talking about the smoothness of the curve, what I actually mean, I will change the color in order to make it much more evident. Let me take the dark blue color. So, when I am depicting the ogive curves, this is a straight line where I draw the color as blue, but the main issue is that the curve, we should basically have such more points such that the smoothness of the curve should be such that the curve which I draw, which is ogive curve, should be a S curve actually for the less than type and the greater than type. And for the other part, which you actually is not an exactly mirror image, but it would basically be a inverted S curve, such that if I draw it separately, the curve should be like this. So, the midpoint which I have, which will give me the median. So, this is the summation of the less than type of or greater than type, and you have basically the class intervals here. So, this value which I have is basically the median. So, this is the median also, and based on it we will say. So, what does the median say? I will come to that again, even though I am mentioning the important characteristics of median time again, but I have not come to what the actual characteristic is. Now, there are few definitions based on the simple problem which you have solved. The class limits are the endpoints under any class. So, if you see the endpoints for the last example, so for any interval, the leftmost point or the rightmost point are the class limits. The class boundaries are the endpoints of any class interval, inclusive or exclusive, depending on how the points have been noted down. Now, we have been drawing the frequencies. So, what is important for us is to note down the relative frequency, and why relative frequency is important, how it leads to the concept of chance, how it leads to the concept of probability, we will come to that later on. But the concept of relative frequency is brought for the first time in the discussion, such that it will give you a good idea that what we mean by probability has a one to one resemblance or one to one correspondence with the concept of relative frequency. So, relative frequency is basically the ratio of the frequency of that interval divided by the total frequency or the cumulative frequency. So, that in a very simple sense would give me the overall probability, overall chance. So, let me give a very simple example. Consider you have a coin. So, whenever I ask the question that what is the probability of getting a head or probability of getting a tail, considering is an unbiased coin. So, obviously, everybody will say that the probabilities are half and half. But now consider that I toss the coin 100 times. So, it may be possible in the first 100 tosses 55 are head and 45 are tail. So, in that case the corresponding frequencies are 55 and 45. Now, if I ask you the question that what is the relative frequencies, obviously you will immediately say that relative frequencies for the head and the tail is 55 by 100, which is 0.55, and for the tail is 45 by 100 is 0.45. But next the question would obviously will come is that if you are saying the probability is 0.5. So, how does 0.55 and 0.45 make sense? The answer is very simple. Consider that you basically do the experiment again, and I will come to this type of experiments more with the tossing of the coin and the rolling of the dice time and again. So, coming back to the discussion, consider you basically toss the coin again, and consider now in this case you have now 60 heads and 40 tails. So, which means the relative frequencies is 0.6 and 0.4. Again you do it now, consider you have 40 heads and 60 tails, the probabilities are 0.4 and 0.6. Now, if you continue doing this you will have different numbers of relative frequencies for head, different numbers of relative frequencies of tail. Now, if somebody is able to do it for infinite time throughout his or her lifetime and it continues, then actually it would mean that the overall averages of these relative frequency in the long run should exactly be equal to 0.5 for the head and 0.5 for the tail, which we are saying are the probability. So, technically probability is the ratio of the frequency by the cumulative frequency or the relative, or actually the relative frequency in the long run, as the number of such observations you take is basically goes to infinite. I will come to that examples later on also. So, let us continue the discussion. So, it says that using the concept of relative frequency and cumulative relative frequency of the less than type or the greater than type, we can also draw the cumulative relative frequency curves or the ogive curves. So, the ogive curves which you have drawn for the frequencies also can be drawn exactly in the similar manner by using the concept of relative frequency, and the general characteristics of the curves would be the same, and the intersection of this less than type and the greater than type ogive curves would exactly be the median point about which I have been talking about for the last few minutes. Now, we will consider some definitions of central tendencies. So, whenever I use the word central tendency, I always mean that what is the overall characteristics of that particular set of values, such that we can have some idea that what is the central characteristics of that data set. So, we know that in general physics, we know that what is the center of mass or center of gravity of a particular body. So, that basically means that in the theoretical sense, the overall pull of that particular gravitational force on that body is, in theoretical sense, is happening through that point, such that if you balance that particular body through the center of gravity or center of mass, the actual body would basically be balanced. So, in the similar way, even though it basically is a way to describe this experiment, this mean value or the central tendency of that particular distribution or particular set of values would be such that they would give me some central characteristics of that particular set of values. Now, central tendencies basically can be measured in three ways. One is the mean, and there are three different means. I will come to that within few minutes. The next one is the median, and the third one is the mode. Now, coming back to the mean, you will basically have three different type of means. One is the arithmetic mean, which is based on which we will do our studies. Next is the geometric mean, which is which is denoted by GM. Arithmetic mean is denoted by AM, and the third one is the harmonic mean, which is basically denoted by HM. Now, the other measures of characteristics of the distribution of the values would be the concept of dispersions. So, the measures of dispersions can be done through the concept of using the concept of variances, using the concept of standard deviation, using the concept of higher degrees would basically come from the concept of using skewness, and the fourth degree problem or the order of the distribution would basically come from the skewness, and so on and so forth. So, but we will mainly pay our attention to the concept of the central tendency, which is the mean, median, mode, and the higher moment, which is the second moment, would basically be coming from the variance or the standard deviation. Variance and standard deviation conceptually are the same. To give a very simple notion, standard deviation is the square root of the variance. We will see that later on. Now, consider there are given n numbers. Now, this number n, it would, whether it is capital N or small n, we will use it interchangeably. So, do not panic over that. Whenever the problem comes, I will mention that very particularly relevant to the problem. Consider there are n number of observations, and they are marked as x suffix 1, x suffix 2 till x suffix small n. So, they consider they are small n number of observations. So, the arithmetic mean would basically be denoted by the weighted sum of those n number of observations. Now, notice very carefully, when I basically add up all the observations x 1 to x n, is technically means the number of such observations which is happening for the x 1th observation, x 2nd, x 2 observation, x 3 observations are 1 at any point of time. So, that means that if I am picking up the chits from the box has 1 to 100 observations, then the number of such chits for the chit marked 1 is only 1, number of chit marked 2 is only 2, that means each of the chit is only 1, then the corresponding average value would be the sum of 1 plus 2 plus 3 till the 100 value divided by 100. Now, the question would be, say for example, what is the arithmetic mean if the chit which is marked 1 appears twice and no number is there for the chit marked 2, 3 happens only once, 4 happens only once, 5 happen only once, and the last one which is dot dot till the last one 100 happen only once. In that case, the average would technically be that you are basically considering the number 1 happening twice. So, obviously, it will be 2 into 1 because it appears twice, number 2 does not appear. So, obviously, it will be 0 into 2, number 3 appears only once, it will be 1 into 3, number 4 happens once, it is 1 into 4, so on and so forth till the last one which is basically 1 into 100 divided by n which still remains 100. Now, in that case, in case say for example, if we have the chit marked 1 as a 50 number of times and corresponding to the chits marked 51 to 100 only appears each appear once, in that case the average would be 50 into 1 plus 2 to 50 numbers would not be present. So, they would be multiplied by 0. The 51st one appears once, 52nd one appears once, and the last one which is dot dot till the last 100 appeared once. So, it will be 50 into 1 plus 51 plus 52 dot dot till the last one 100 divided by 100, because the 100 number of observations remains the same. Now, when I mean the word geometric mean, basically it will give me the value and given the formula x 1 which is the corresponding value which I am getting, x 1 into x 2 into x 3 dot dot till the nth one x n, all these things multiplied together and we find out the 1 nth power of that particular multiplied value. In the case when you have the harmonic mean, basically what I do is that I find out the average of the inverse of these values starting from 1 by x 1 till dot dot till the last one which is 1 by x n. So, obviously, the problem which I said, if the chits marked 1 appears twice, chits marked 2 does not appear, chit marked 3, 4 till 100 appears once, then obviously, the corresponding value of the formula for the formula remains the same, the values basically change accordingly how you are using in the geometric mean concept and the harmonic mean concept. Now, before I discuss, let us consider the concept of arithmetic mean, the geometric mean and the harmonic mean. So, consider one example in each. Consider you have 10 number of students and you want to find out the average height. So, average height of all of them are given like this. Let us consider and have a little example. The first one has a height of 5 feet 2 inch, second person has a height of 5 feet 3 inch, third person has a height of 5 feet 10 inch till the last one. So, if I want to find out the average height, what I will do is that add up all the weights, all the heights, divide by the number of people who are there and basically give the result. And another second example consider for the arithmetic mean is that, say for example, I have the weights, I want to find out the average weights, what I will do is that basically find out the sum of the weights divide by the number of people who are there for whom I am trying to find out the average weight. Consider the third example, I want to find out the value of when you basically are rolling a die and the values which are coming up and this die is an unbiased one. So, the faces marked are 1, 2, 3, 4, 5, 6. So, if I want to find out the average value which is comes out, basically what I will do is that add up all the values 1, 2, 3, 4, 5, 6 divided by the number of readings which is basically number of such happenings which can happen is basically 6 and I find out the average. Now, consider the next example when I want to find out the geometric mean. So, geometric mean example can be given in a very simple way. Consider that you have some money 100 rupees and you basically you invest that money in the bank and you get an interest of 10%. So, after 1 year that 100 rupees basically becomes 100 plus 10% of 100, which is 10 rupees. Then again you basically take out that money and immediately put in the bank, and the interest rate basically now is, say for example 20 rupees. So, in that case what you will do is that, and consider your interest rate is only being paid for the principal amount. I am not going into the concept of compounding interest rate, I am only considering the concept of simple interest rate. So, in the next year the interest rate is 20%, consider in the next and the third year it is the interest rate is 15%, and fourth year consider the interest rate is 20%. So, my main question, or you may basically may be interested to ask, is that what is the average interest rate based on which I can find out that the value which I get for this different type of interest rate, actual value exactly equals to the value which I get using the so called average interest rate which I want to calculate. So, in that case the calculations which I will definitely discuss in the later examples, but it will be like this. So, the interest rate at the total value which I will calculate for the 4 years would be like this: 100, which is the principal amount, multiplied by 1 plus 10% which is for the first year, multiplied by 1 plus 20% which is for the second year, sorry, multiplied by 1 plus 15% which is for the third year, multiplied by 1 plus 20% which is for the fourth year. So, in that case the values would be accordingly found out like this. Let me use the red color. So, this is the principal amount, consider this is 100 for the time being. So, it will be for the first year it will be 10%. The second year it was basically 15%. For the I did mention, let me recollect, I think I mentioned these 20% for the second year, 15% for the third year, and another 20% for the fourth year. Now, I want to find out equivalent interest rate for the using the concept of geometric mean. So, obviously, it will be 100. How many years are there? There are 4 years. It would be 1 plus r by 100 to the power 4, because there are 4 years. Based on this 100 cancels. You will basically have 1 plus r by 100 to the power 4 equate it to 1 plus 10 by this is the second year, third year, fourth year. From this you can find out the interest rate for the average interest rate using the concept of geometric mean. So, I will come to the harmonic mean later on also. So, let me continue reading it. This one, when estimating the long term expectation of random variable, the arithmetic mean is a natural choice. That is, example, finding the average age of a group of person, average income of a group of people. Based on this we can do the calculation. So, with this I will end the third lecture and continue discussion more about the examples of harmonic mean, geometric mean, and then further go on to the concept of dispersions and discuss variance and standard deviation in more detail. Have a nice day. Thank you very much.